Where do we come from? It's a question humans have pondered for centuries. We look to the stars, those distant suns scattered across the cosmos. Could the answer to our origins lie among them? The universe holds many mysteries. One of the most profound is the connection between humanity and the vast expanse of space. We are made of atoms, the fundamental building blocks of matter. But where did these atoms originate? The answer lies in the fiery hearts of stars. Our very existence is intertwined with the life cycle of stars. Stars forge elements like carbon, oxygen, and iron through nuclear fusion. When stars explode as supernovae, they scatter these elements across the universe. These elements eventually coalesce to form new stars, planets, and even life itself. The very atoms in our bodies were once part of ancient stars. We are quite literally made of stardust. Consider the human body. We are a complex assembly of elements: carbon, hydrogen, oxygen, nitrogen. These are just a few of the ingredients in the recipe of life. They form the basis of our DNA, the blueprint of who we are. These same elements are found throughout the universe, but how did they come to be within us? The answer lies in the extraordinary processes that occur within stars. Stars are cosmic furnaces constantly churning and burning. Inside their cores, intense temperatures and pressures forge lighter elements into heavier ones. This process, known as nuclear fusion, is the alchemy of the cosmos. When massive stars explode in supernovae, they scatter these elements across the galaxy. These elements eventually coalesce into new stars, planets, and even life itself. On Earth, these building blocks combined in unique ways to create the diversity of life we see today. From the simplest microorganisms to complex beings like us, all life shares this cosmic heritage. Imagine a massive star millions of times larger than our sun. Inside its core, hydrogen atoms fuse to form helium. This releases tremendous energy, powering the star and causing it to shine. As the star ages, it begins to run out of hydrogen fuel. The core contracts and heats up, allowing helium to fuse into heavier elements like carbon, oxygen, and nitrogen. This process of nuclear fusion continues, creating heavier and heavier elements until the star's core is primarily iron. Iron is the end of the line for fusion in stars. At this point, the star's core can no longer support its own weight and collapses in on itself. This triggers a supernova, a catastrophic explosion that spews the star's contents, including the newly formed elements, out into space. These scattered elements, forged in the heart of a dying star, become the raw materials for new stars, planets, and even life. We call this cosmic debris stardust. It drifts through space, carrying the building blocks of life to distant corners of the universe. And it is from this stardust that our solar system, our planet, and even we ourselves were formed. Billions of years ago, a cloud of stardust and gas collapsed under its own gravity, giving birth to our sun and the planets that orbit it. Earth, in its infancy, was bombarded by asteroids and comets, delivering water and organic molecules. These cosmic ingredients formed in the crucibles of long-dead stars provided the necessary components for life to emerge. Supernovae, the explosive deaths of massive stars, scatter heavy elements like iron and gold into space. These elements enrich the interstellar medium, contributing to the formation of new star systems. Remarkably, the very atoms in our bodies, such as carbon and oxygen, were once part of ancient stars. This cycle of star birth and death drives the evolution of galaxies, shaping the universe as we know it. From cosmos to cells. The journey from stardust to living organisms is a long and complex one. Scientists are still piecing together the details of how life arose on Earth. But we know that the elements forged in stars are essential for life as we know it. Carbon, with its unique ability to form complex molecules, serves as the backbone of all organic molecules. Oxygen is crucial for respiration, the process by which organisms convert food into energy. Nitrogen is a key component of amino acids, the building blocks of proteins, and water, the universal solvent, provides the medium in which all of life's chemical reactions take place. The early Earth was a volatile environment with volcanic activity and lightning providing the energy needed for simple molecules to form. These simple molecules eventually combined to form more complex structures, leading to the first microbial life forms. Over billions of years, these early life forms evolved, giving rise to the incredible diversity of life we see today. The seeds of life. The elements of life scattered throughout the universe by supernovae are found in every part of our bodies. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were created in the hearts of stars that lived and died long ago. We are literally made of stardust, our very existence intertwined with the cosmic events that transpired billions of years ago. The concept of stardust is not merely a poetic notion, it is a scientific fact supported by a wealth of evidence. Astronomers can analyze the light from distant stars and determine their chemical composition. They have found that stars, like our sun, contain the same elements that make up our bodies, albeit in different proportions. Elements such as carbon, nitrogen, and oxygen, essential for life, are forged in the nuclear furnaces of stars. These elements are then spread across the galaxy by stellar winds and supernova explosions. Meteorites that have fallen to Earth also contain these life-giving elements, providing further evidence of our cosmic origins. Life on Earth is a testament to the incredible journey of these elements, from the hearts of stars to the building blocks of life. Are we alone? The realization that we are made of stardust has profound implications for our understanding of our place in the universe. It suggests that we are not isolated beings confined to a single planet. Instead, we are part of a vast and interconnected cosmos, linked to distant stars and galaxies by the very elements that make us who we are. It also raises questions about the possibility of life beyond Earth. If the ingredients for life are common throughout the universe, then it is plausible that life may have arisen on other planets as well. Perhaps, somewhere out there, other beings are gazing up at the night sky, pondering their own cosmic origins. Recent discoveries of extremophiles on Earth, organisms that thrive in extreme conditions, suggest that life could exist in harsh environments on other planets. For instance, Jupiter's moon Europa is believed to have a subsurface ocean beneath its icy crust, which could harbor life. Mars, with its ancient riverbeds and evidence of past water flow, remains a prime candidate for the search for past or present life. Additionally, the discovery of exoplanets in the habitable zone of their stars, where conditions might allow for liquid water, further fuels the possibility of extraterrestrial life. A cosmic connection. The connection between humanity and the cosmos goes beyond our physical bodies. The stars have captivated our imaginations for millennia, inspiring countless myths, legends, and scientific discoveries. From the ancient Egyptians who used the stars to navigate to the modern astronomers who study the universe with powerful telescopes, humans have always sought to understand our place in the grand scheme of things. The realization that we are made of stardust adds a new dimension to our cosmic connection. It reminds us that we are not separate from the universe but rather an integral part of it. The atoms in our bodies were once part of stars that exploded billions of years ago. We are literally children of the cosmos, born from the ashes of stellar death. Nearly every element on the periodic table was forged in the heart of a star. Cosmic rays, high-energy particles from space constantly bombard Earth, influencing our atmosphere and even our DNA. The gravitational pull of the moon affects our tides, while the sun's energy drives our climate and weather patterns. Our Milky Way galaxy is just one of billions in the observable universe, each teeming with stars and potentially life. This vast cosmic perspective deepens our understanding of life's interconnectedness and the universe's profound influence on us. A universe within. The next time you look up at the night sky, take a moment to ponder the incredible journey that brought those atoms to your eyes. The light from those distant stars has traveled for millions, even billions of years to reach us. It carries with it the story of the universe, from the Big Bang to the formation of stars and galaxies to the emergence of life on Earth. We are all made of stardust, a testament to the interconnectedness of all things in the universe. Our bodies contain elements like carbon, nitrogen, and oxygen, forged in the hearts of stars. As we continue to explore the cosmos, we will undoubtedly make new discoveries that further illuminate our place in the grand tapestry of existence. The very DNA in our cells is a record of the evolutionary journey that began billions of years ago. From the chaos of the early universe, life emerged, evolving into the complex beings we are today. Truly, we are a universe within, a grand design of life that reflects the cosmos itself.